This lesson will go over the area of triangles and parallelograms. As a refresher, area is the amount of space inside a flat two-dimensional object, and it is measured in squared units or units squared. The formulas for area of a triangle is area equals 1/2 base times height. I do want to point out that the idea of height is that height is always perpendicular to the base. So a lot of students think that base means bottom. Base is whatever the perpendicular height is attached to. So if you were to draw your triangle out differently, the base is wherever the height is drawn. So base and height are connected. It's not necessarily base is bottom. Area of a parallelogram or a rectangle, remembering that a parallelogram or that a rectangle is a parallelogram, is the area of the base times the height again. And again, height is perpendicular, so whether I draw height out here, it is still perpendicular to the base. These dotted lines are used often when they are imaginary, where they're not necessarily part of the diagram, but they're there to help you realize what should kind of be there. So base, again, not necessarily meaning bottom. If I turned this shape on its side, I could still have a height as long as it was perpendicular to a base. So again, it says note, height is always perpendicular. Height may also be outside. Probably shouldn't have put triangle, but outside the figure as well. So here are 4 different problems. I'm not trying to trick you. Things that look like parallelograms are parallelograms. Things that look like squares are squares. I should be more specific. I should have labeled them, but I didn't. So this first one is a triangle. Area of a triangle is 1/2 base times the height. If you notice the perpendicular, that means this is the height. This dotted line isn't part of the triangle, that's why it's dotted. The base of the triangle is right here. Even though the base and the height aren't connected, they're still married by this perpendicular. So it's 1/2 6 times 7. Half of 6 and 7 is, well, half of 6 is 3, so that's going to be 21 units squared. For the next one, this is a parallelogram. Not trying to fool you. So if you notice, there's going to be this perpendicular height right here and that dotted line. So this is going to be your height. The base is what that height is married to. So this entire length from here to here is the base. If you know, think back to what you know about a parallelogram. The opposite sides are congruent. So because this whole side length is 8, this whole side length is 8 as well. So the base has a side length of 8. The reason why this 3 is here is because we need to use it to find the height. So we have a right triangle, and we can use Pythagorean theorem to say that a squared plus b squared is equal to c squared. So that's going to give me 9. Sorry, I'm sideways. When I subtract the 9, that gives me 16. So h equals 4. So the area is going to be base times height. So it's 4 times 8, which is 32 units squared. Going down, letter C is a square. I'm not trying to trick you. Should have been more proactive with labeling, but it's a square. What you know about a square is they have 90 degrees and all 4 sides are congruent. Because it's a square, area is going to equal base times height. The only difference here is that the base and the height are the same. If you notice though, what you're given is the 15 isn't the base or the height. This would be height, this would be base. The 15 is the diagonal, or even referred to as the hypotenuse. If you think about the 45 here, we have a 45, 45, 90. And in a 45, 45, 90, the hypotenuse is equal to the leg times the square root of 2, and in this case the leg is either the base or the height. So the hypotenuse, which is the diagonal, is 15. Leg times the square root of 2. I need to get the leg all by itself, do that by division. So the leg here is equal to 15 square root 2. So that means this is 15 over the square root of 2, and this equals 15 over the square root of 2. So area equals 15 over the square root of 2 times 15 over the square root of 2. Your calculators may be able to handle this if you enter it properly, but when we multiply tops and tops, bottoms and bottoms. So if I were to do the square root of 2 times the square root of 2, I get the square root of 4, which is just a plain old 2. So it turns into 225 divided by 2, which is 112.5 units squared. And then lastly, letter D is a rectangle. And I should have labeled it as a rectangle, or the corners is 90 degrees. But in a rectangle, area equals base times height. So here is your height and here is your base. But if you notice, you're not given any. What you're given is a diagonal. So what we have is a 90-degree angle. You're going to be using sine, cosine, SOHCAHTOA in order to find your H and your B could also go up here. So if this is my reference angle from the 56, this side over here is adjacent, this side here is opposite, and this is the hypotenuse. So I'm going to be using sine in order to find B, and I'm going to use cosine in order to find H. So in order to find the value of B, I'm going to use 56. B is opposite over hypotenuse. So the sine of 56 equals opposite over hypotenuse. Then when I go to find cosine, the H is adjacent over hypotenuse. So that's cosine. Cosine of 56 equals adjacent over hypotenuse. In order to get the variables by itself, I'm going to multiply that by 21. I'm going to type in my calculator 21 times the sine of 56, and I'm getting B is 17.41. I'm going to do the same thing over here to get the H by itself, multiply both sides by 21, and I'm getting that H ends up equaling 11.71? Yeah, 11.71. So an area equals 1/2 base times height. And grab your calculators for this. I got 204.4 units squared. So there you have it. Area of a rectangle and a parallelogram and a square and a triangle, high school geometry style. Let me know if you have any questions.